Okay, today we're going to talk about compositions of isometries. And composition means that we're going to combine, obviously, two functions, and isometry means we're going to combine two rigid functions. So these are um, transformations where the size and shape doesn't change, just the location. So if you remember, there's translation, rotation, reflection, and then glide reflection. And the glide reflection is a combination of the translation and a reflection. And those are the ones that we're going to practice today. And they're specifically called glide reflection. Okay, this is in 9.4 in your book. Okay, so the first one we're going to do is we're going to do the reflection of the translation of triangle TEX. And I read it that way because this open circle right here is actually composition. And so what it means is that we're going to translate it first and then reflect it. So when we do these, we're always going to do whatever comes last first, and then whatever comes first last. Okay, so that's the one thing we have to remember for this. So we are going to reflect the translation. So in order to do that, we're going to have to actually do the translation first. So with our compositions, we always do the second transformation first, and then we do the next one, and then complete first transformation. Okay, so we're going to start with this one. So I'm going to first write down for TEX, this triangle text. I'm going to write down the actual coordinates that I started with. And T looks like it's -5, 2. And E looks like it's -1, 3. And X looks like it is -2, 1. And as you work through these compositions, one thing that you'll notice is that in some of the compositions, we could actually do it in either order and get the same thing, which we just get lucky because the reality is for most of them, that's not going to happen. We're actually going to have to do it in the reverse order, second, first, in order to get the right figure. So the first thing we're going to do is translate, and then we're going to translate +0 to x and -5 to y. So a capital T, I'll put that rule or notation right there. And so then I'll say, what are my next points going to be? So T is going to become -5, so we added 0 to x. And then we're going to subtract 5 from 2, so -3. E is going to become -1, -2. And x is going to become -2, comma, -4. Okay, so go up here and we'll plot those points. So E was -1, -2, so that's where my new E is going to be. And then -5, -1, 2, 3, so that's where my new T will be. And -1, 2, 3, 4, and that is where my new X is going to be. So we'll connect those points as best we can. Okay, and I'm going to go ahead and make that one red so we can keep it straight which movement's going which way. So now we have done the first transformation. We've actually translated. Now the next thing it asks us to do is to reflect this translation over x equals 0. So I actually need to figure out where is that line of reflection. So where on the graph does x equal 0? Well, it turns out x equals 0 right here. And since it's x equals 0, we know that it is a vertical line. So it's going to run right along the y-axis. So we're going to reflect over this line. And so I need to kind of think for a second, what was my rule or my pattern for that when I reflected across the axis here? If I reflected across the y-axis, only my x values would change, right? So I would say that's going to mean that x comma y will become negative x, or the opposite of x, and then y will actually remain the same because we're not moving up and down. We're just reflecting across that way. So I go back, not to the original points, but to these points that I just created. Uh-oh, that's not the right arrow. Okay, and we'll see what happens if I reflect these points over. Go ahead and write. Remember, reflection is capital, so reflect over y equals 0. Oh, and I wrote it wrong. Just kidding. We're reflecting over x equals 0. Now we got it right. So now t is going to become, if you notice, my y is not going to change, and my t is going to be negative. Since it's already negative, it becomes positive. So that's going to be 5 comma negative 3. And then e double prime is going to be 1 comma negative 2. And x double prime is going to be 2 negative 4. Okay, and these are double prime because it's a transformation of the translation, one that's already occurred. Okay, so things have been moved twice. So we'll go up here and we'll plot our points. So if I'm looking for t, I'm going to go 1, 2, 3, 4, 5. 1, 2, 3. So that's going to give me t. And then e is going to be 1, 1, 2. So that's going to give me e. And then x is going to be 1, 2, 4. So it's going to be right there. So let's connect them. Okay, and then I'll make them green so we can kind of see what we've done here. So if you look, make this maybe purple. Okay, so if you look, basically we have translated and then reflected. So the final image, which remember this right here is the image, right? The final image is the reflection of the translation. Again, always doing the second thing that's listed first, and then do last. Okay, so that's how we do compositions. And so on your own paper, you can get some 10 by 10s because it looks like I think they're all going to fit. If you did 10 by 10, you need to do 12 through 15, and this is in your textbook on page 574. And if you notice, these are all glide reflections. Okay, so and a glide reflection is a specific composition where it's translated and reflected. Okay, and that's your compositions.